All right, class, welcome back. This is part 2 of the 1.1a lesson video. Uh, in the interest of time, I'm not going to go over all of these problems for number 7, but what I will do is I will choose some challenging ones and go over them. So how about let's try the letter D, G, and H. Okay, so remember, as discussed in the previous video, you want to make sure that you're comfortable with the order of operations. You want to make sure that you know parentheses always goes first as your first step, followed by exponents, multiplication, division, addition, and subtraction. Okay, so when I see something like letter D, I immediately have my attention at the group 8 minus 2, and that's going to be 6. And then I also have another group right here, which is 1 plus 3, which is 4. So if you want to rewrite this, you can write 11 plus 6 times 8 divided by 3 times 4, right? So we know that multiplication is the next step. So you know that it's 11 plus 48 divided by 12. And we then know that division is the next step. So you cannot do 11 plus 48. You do 48 divided by 12, which is 4. And then you get 11 plus 4, which gives you 15. Okay, pretty simple, pretty straightforward. Follow the steps. Okay, obviously these are all good practice problems. But what I did want to talk about was something like letter G. We have to remember a few things here. We want to add fractions that don't have the same denominator. And first of all, though, I could put parentheses around these two terms because that's essentially the first step, right? We have to do 1/9 divided by 1/3. Now, if you remember, dividing fractions is kind of like multiplying by the second fraction's reciprocal, right? So this is if it's 1/9 divided by 1/3, that's the same thing as saying 1/9 times 3 over 1. You may remember this from last year, right? If you take a fraction divided by another fraction, you basically have to flip the second fraction and make it its reciprocal, and you then get 1/9 times 3 over 1, and then we know that we could cross simplify this to make this 1/3. Okay, so this entire thing is 1/3, and now it actually makes our life a lot easier. I'm going to rewrite the problem and write it as 2/3 plus 1/3 plus 5/6. Okay. So there are shortcuts to this. You definitely don't need to necessarily make this a common denominator because you know that 2/3 plus 1/3 is already 1. So if you already know that this is 1 whole, you kind of already know that this is 1 and 5/6. Right? Because this is 1. 2/3 plus 1/3 is 1 whole. And 1 whole plus 5/6 is 1 and 5/6. Now, obviously, you could have left it as an improper fraction, and the improper fraction version is 11/6. In this class, I will allow you to write it in both the mixed number format and the improper fraction format. And actually, you'll see later on that the improper fraction is more useful. Just remember to always simplify and make sure that your fraction is in simplest form. Okay? Let's try letter H. So right now, again, I have my attention on the 4 times the 1/8. I also have my attention on the -2 divided by 2/5. Okay? So this 1/4 is kind of like on its island. You always do that step last. So I'm going to go ahead and just drop it down, 1/4. 4 times 1/8 is actually 4/8. And then -2 divided by 2/5. Well, remember, that's like -2 divided by 2/5. And that actually is kind of like saying -2 times 5 over 2. And because I have a 2 on the top and the bottom, we're allowed to cross simplify this. And this ends up being -5 entirely. Okay? So this whole part was -5. So now I can kind of write it like that. Okay, so I have 1/4 plus 4/8 minus 5. Okay, so I'm actually going to finally convert them all to the same denominator so you can see what it looks like. The common denominator here would be, well, wait a minute. Doesn't 4/8 simplify to 1/2? And couldn't I make this technically 2/4, right? Isn't 4/8 equivalent to 2/4? So I'm going to get 1/4 plus 2/4 minus 5. 5/1. So then I'm going to make this out of fourths, and you can see that this is 3/4 minus 20/4, which ends up being, now that they have the same denominator, I could add the numerators, and it's really just 3 plus -20, which is -17/4. Okay. Again, as long as you keep your improper fraction simplified, that could be your final answer. Okay. Hopefully this was a good review for you. The order of operations really is not that difficult. But let's go down to our next problem, which is kind of like an extension word problem. And let's go ahead and talk about this one. Okay. So it says, I'm trying to decide if we should do this in the video or should I make this done in class. Okay. Let's go ahead and do this right now then. It says Emma is playing a popular video game and is determined to beat the high score. The game saves her place so that each time she plays it again, she picks up in the same place with the same number of points. Emma downloads the video game on Monday night and starts playing, scoring a bunch of points. On Tuesday, she scores an additional 500 points. On Wednesday, she doubles her score from the previous day. On Thursday, she scores the same number of points that she scored on Monday. Okay, so it's kind of like you have to understand what we should set as her first initial score. Sam writes an expression that it represents Emma's total score after she's finished playing on Thursday. Sam writes the expression 2 parentheses p plus 500 plus p. Write in words what each piece of Sam's expression represents in the story. So I think it's always helpful to annotate a little bit. So she downloads the game on Monday night and she scores a bunch of points, right? And then on Tuesday, she scores an additional 500 points from the, in addition to what she scored on Monday. So I think from that, you already can tell that P is going to be Emma's score on Monday. Okay. And then Tuesday, she scores an additional 5 points. So you could say Tuesday's score. Wednesday, she doubles her total points. And you can see that if you want to double something, you definitely want to put that expression in its own group, and then you double it that way, right? If you just put a 2 in the front of the P, that would only mean doubling Monday's score plus 500. That's not the same thing as doubling Tuesday's score. So this is going to be Wednesday's score. And then Thursday, she scores the same number of points that she scored on Monday. Okay. So if she scores the same amount of points that she scored on Monday, then it's kind of like her Wednesday score plus this Thursday addition is going to be Thursday's final score, right? Total score. Remember that all of the scores are continued from the previous day. All right. So if you remember from previous classes, you know that a term, a number outside of the group like that must be distributed, right? So you're going to have to distribute this too, and write two more expressions that can also represent Emma's total score. So can you give me two more equivalent expressions? Well, obviously this is not simplified. So if I really wanted to simplify it, I could start by doing the distributing the two, and I can get 2p plus 1000 plus p. That would be one example of an equivalent expression. And then if I were to combine like terms, right, the variable p with the variable 2p would give me 3p plus 1000. So these are both basically describing the same exact situation. Okay, I'm going to leave the rest up for you to work with, and I'm actually going to skip to the last page that I want to talk about, which is simplifying expressions, right? This was that's what the entire lesson was about, simplifying expressions. There's so many little details that we have to pay attention to. And if there's one detail that I want you to take away from today, uh, obviously, the order of operations and PEMDAS is important. But here, I want you to put a star, first of all, next to this number 13, because number 13 describes a situation where there is it looks like a minus sign, but you also have to treat that as a negative sign outside of the group. Okay? So there's a group right here, x minus 2, and there's a minus or a negative sign right outside of the group. For this reason, you must distribute the negative. This is one of the most important things that you need to practice this year, which is understanding when to distribute. And even if there's not really a value, it seems like there is still a -1 outside of there. So you have to distribute the negative here, and you have to distribute the negative there. Okay, so I'm going to rewrite this entire expression. The 12 obviously drops down, and you get 12 minus x plus 2, because remember, this is kind of like the opposite sign, right? So this x becomes the opposite of positive, and this -2 becomes the opposite of -2, which is positive 2. So I get then the 4x obviously continues and joins the party. Okay, so now when you have it here, you kind of already know that variables are always combined first, because that's kind of like the standard form. You always want to combine variables first, and you get -x plus 4x, which is 3x. Then you have 12 and 2, which is 14, and always box your answer. This is the type of work that I expect to see on your homework. Remember that you always want to practice the way you expect to complete things, and I want you to practice this on your lesson. I also want you to do this on your homework. Okay. Yeah, the others right here are good practice problems that we can do in class. So I'm going to keep going, and let's do one last problem regarding substitution, right? Plugging in values into variables. It says evaluate the expression y equals -2/5 and n equals -2. So both of these are negative, which is kind of interesting, and you're going to have to plug in. Okay. So the very simple way is the way I like to do it is I see how it's 7n plus n. Well, first of all, if you can simplify the expression, please simplify it before you plug in any values, right? That would make your life a lot easier automatically. This is 8n, and then you just get 8 times, well, what did n's value equal? It equaled -2. So it's really -2, or 8 times -2, which ends up being -16. Box your answer. Now you might say that's pretty easy, Mr. Quo. Let's go to number 19, and I'm running out of time, but let's do the same thing. -4 minus 1 over, and use parentheses before you plug in, right? I'll talk about that more in class, but you always want to use parentheses because it protects you from these double negatives. So this already is a double negative, and I'm going to tell you right now, this would be -4 plus 1 over 2, because the negative and the negative made it a plus. And -4 plus 1/2 is equal to